So, hi everyone. I'm Pavol Rusnak, or known as Stick in the Bitcoin community, and I'm the co-founder of Satoshi Labs, the company that brought Trezor. And today I'm going to be talking about challenges implementing coinjoin in hardware wallets. But first, maybe just summarize why privacy matters. There are a lot of reasons, but I think these are the most important. Autonomy, because privacy allows individuals to have control over their personal information, enabling them to make independent choices and decisions. Then, personal safety. Privacy protects individuals from harm or danger, such as stalking, harassment, or identity theft. Freedom of expression. Privacy encourages free expression and open communication. Trust. Privacy is essential for building trust between individuals and institutions. Then, equality. Privacy helps ensure that everybody is treated equally, regardless of race, gender, religion, and so on. Democracy. Privacy is really critical to maintaining democracy by enabling citizens to communicate freely with one another and their representatives. And last but not least, innovation. Privacy promotes innovation by providing a safe environment for individuals and companies to experiment and develop new ideas and technologies without fear of theft and abuse. So it can be summarized that privacy is a fundamental human right that protects individual autonomy, safety, freedom, as well as promoting trust, equality, democracy, and innovation. So where do we stand? What's the state of Bitcoin privacy? Transactions are recorded on a public blockchain, can be traced and analyzed by anyone, even retroactively. Identity of transaction parties is not necessarily known, but these identities are very often linked through various means. So that means IP address tracking, public information disclosure. You know, if you put on your Twitter or Nostr profile, hey, this is my Bitcoin address for donations. And especially in combination with address reuse, this is a big issue, but not as big as Exchange and their know your customers practices. What are the privacy enhancing technologies? So there are confidential transactions, which is a method which obfuscates transacted amounts, but we need to verify that no bitcoins were created or destroyed in the process. And these are usually deployed as sidechains. We don't have confidential transactions in the Bitcoin base layer. Then there is Lightning Network, which helps with privacy because blockchain now shows only channel opens and closes, but it doesn't show individual transactions. There are services like Tor and VPNs where you can hide your user's IP address and thus location. And it's harder to link transactions together because, for example, in Tor, you can switch identities when performing different transactions, and then you seem as a different person online. And of course, there is coinjoin. So what's coinjoin? It's privacy-enhancing technique to increase the anonymity of Bitcoin transactions. And it happens when multiple parties agree to merge their transactions, meaning inputs and outputs, into a single larger transaction. And the resulting transaction makes it more challenging to link individual inputs and outputs to their respective owners. So usually, a coinjoin is much bigger than this, but this is just an example. You see there are 3 participants on the input side, and by looking at the output side of things, you can probably guess that this change output belongs to that person, and so on. But you can't really tell nothing about these outputs. You don't know whether this output belongs to that person or that person or that person. So basically, the idea is let's create outputs of the same size, and these clusters of same-sized outputs they gain something that we called K anonymity. So this group of outputs have K anonymity where K is 5, because you can't really guess which person this output belongs to. What are phases of a coinjoin? First, there is input registration, where each participant registers their input at the coordinator. This happens usually via Tor, so different Tor identity is used for each input. And for each successful input registration, a coordinator gives participant something I will call a token, but it's not like a cryptocurrency token. And it can be, for example, a show me on blind signature that's used in Wasabi 1, or keyed verification anonymous credential, which is used in Wabi-Sabi protocol in Wasabi 2. I really don't get into the details what this actually means, but the important thing is that you are given this token, and you can use this token in the second phase, which is output registration, where each participant registers their outputs at the coordinator via different Tor identity again. And what's important here is that these are different identities than used in the input registration, so there is no link. And each output registration presents a token, which is a proof that you are allowed to register output of a certain size. And this token is burned, which means essentially that the CoinJoin coordinator marks it as used. And usually this token is tied to a CoinJoin round, so it's not usable in another round. And that's good, because then this marked or used list can be discarded after the CoinJoin round. They don't grow infinitely over the time. There are certain techniques where these tokens are not limited to a certain point of time, but then we are talking about various eCash implementations such as Cashew or Fedimin. But back to CoinJoin, these tokens are limited just for this particular round. And then there is signing. So after inputs and outputs registration phase, we compose the transaction and send it to each participant to be signed. We can use different identities, but it doesn't really matter. We can even use identities from step 1, because if you were registering input in that phase, it's 100% sure that you will be signing the same input in that case. And all signatures are collected from participants, and when the final composite transaction is valid, then the CoinJoin round is successful and transaction is broadcasted to the network. What about the hardware wallet? Usually, if you have a regular transaction on CoinJoin 1, a hardware wallet signs transactions with user interaction. What it means? It means that user confirms output addresses, which is basically output scripts. Then the user confirms output amounts and mining fee, which is usually sum of outputs minus the sum of inputs. Sorry, it should be the opposite. And there is an asterisk there, because usually hardware wallets, if they don't detect extremely high fees, they don't really ask about this. So I will talk about it a little bit later. And for CoinJoin, we need transaction signing with no user interaction. Why? Because we don't really know when the other parties are ready for signing and when we reach the signing phase. And usually we need more CoinJoins round than one, and we really don't want to force users to sit in front of their computers for 2 days or something like that. And in that case, a hardware wallet needs to do several things. So it has to check if sum of my inputs equals sum of my outputs plus small epsilon, which is mining fee, coordinator fee, and so on. And the trick here is how to correctly identify which inputs are mine, which outputs are mine, and of course, their amounts. So let me talk about pre-segwit fee attack or spoof input amount. The idea is that sum of inputs minus sum of outputs is the mining fee, but transaction inputs do not contain any amounts. They contain just the transaction hash and transaction index. So what if an attacker lies about amount of an input? Then you can, for example, spend 10 BTC input, but lie that is only 1 BTC. Remember that on hardware wallet, you just confirm the outputs, not the inputs. And then a user will spend 9 Bitcoins on transaction fees. So on Trezor, we always require full previous transactions, so the hardware wallet can compute the real input of which is being spent. And this can be a little problematic when the transactions you are spending are pretty big. And as I said, when the fee is high, we show a warning. When the fee is very high, we throw an error. If the fee is below this threshold, then we just let it pass. So there was a SegWit version 0. Does it fix this? BIP 143 signatures commit also to the amount of spent input, which is good. And if the attacker lies about the UTXO amount, then the signature is simply not valid in the Bitcoin network. Are we done? Well, no. Because SegWit version 0 does not fix this entirely. Why? Imagine the victim has two BIP 143 UTXOs of 15 and 20 BTC. The malware asks the user to confirm the transaction, which takes input 1 as 15 BTC input and input 2, and it presents it as it has only 5 Bitcoins plus 1 Satoshi. BTC, then the user chooses the outputs and will exchange output if necessary. The user confirms transaction. They only confirms the outputs. And they think they are spending 20 BTC plus 1 Satoshi fee. Then the malware throws an error and tells the user to confirm the transaction again. But this time, the malware uses input 1, but tells the hardware wallet, hey, this is just 1 Satoshi, and input 2 as 20 Bitcoins. So from the user's perspective, they don't see the inputs, they just see the output side of things. So it's the same transaction as they were signing it earlier, and the user sees an apparently identical transaction, and again, confirms spending 20 BTC plus 1 Satoshi, but actually they spend 15 plus 20 BTC when the malware combines these two signatures and creates a transaction that spans both of these. So this means that, again, 15 Bitcoins are spent as a transaction fee. Then there was SegWit version 1. Does it fix this? Now, BIP 341 signatures commit to all input amounts. That's great. So all signatures in the transaction commit to all input amounts. They also commit to the input script, which is great, and the attacker cannot really modify the input script. But are we done? What do you think? No. Not yet. The attacker can also lie about the input script, that it doesn't really belong to the wallet, and fool the hardware wallet into not taking this input into account. And you can again perform the same two-pass signing, extract and collect two signatures, combine them, and do essentially the same attack. This issue was encountered by my colleague Andrew Kozlik in 2020 while working on coinjoin, and he immediately proposed that BIP 341 signatures should commit to all input scripts, not just the one input script that is being signed. And luckily, there wasn't a very long discussion, and all parties really agreed that it should be done this way. There is no reason why not to do it. So SegWit version 1 does fix this issue, and SegWit version 1 input signatures commit to previous transaction hash, pref index, amount being signed, all amounts in the transaction, input script being signed, all input scripts. So yeah, essentially, this is why CoinJoin really loves Taproot, because having signatures that commit to everything is great for automated transactions containing external inputs, for example, coinjoins. And attacker cannot really change input amount or input script, because if they do, then the whole transaction is ruined because of the wrong signature. And there is one more thing we have to figure out, and that's attacker could still withhold some kind of information. For example, whether the input belongs to the hardware wallet. Maybe the attacker doesn't really want to tell the hardware wallet which BIP32 path is being used, and it's really impossible for hardware wallet to figure it out on their own, and the input would not be taken into evaluation. So we need to somehow ascertain ownership of all inputs. So how do we do that? Yeah, and this is important for all transactions with external inputs. Not only for CoinJoin, but also like dual-funded Lightning channels, etc. And we need a mechanism to reliably determine for which input whether it belongs to the wallet or not. So how do we do that? This is described in SLIP 19. SLIP is like Satoshi Labs equivalent of BIP. And the SLIP 19 is named proof of ownership, and it works that way. We have essentially three pieces of information which are signed. The first is ownership identifier, which allows us to efficiently determine whether the wallet is able to spend and UTXO having a given script pub key or not. It's a very simple construction where basically you take a symmetric key derived from master seed and then use HMAC to process this key and the script pub key as its message. Then other piece of information is the script pub key itself. And then also we have added additional commitment data, which are arbitrary. You don't even have to use that if you don't want to. But basically, it's a random 256-bit value, which in case of CoinJoin, we use 192-bit CoinJoin coordinator ID and 64-bit CoinJoin round ID. But it can be any value depending on what kind of application are we building. And everything is signed via a method described in March 2020 edition of BIP 322 generic signed message format. So maybe I will end my talk by asking why people do not use CoinJoin much. So first of all, I guess the real issue here is lack of awareness, which hopefully I'm kind of fixing now. People don't know that CoinJoin exists. People don't know they need privacy at all. They maybe don't care about privacy at all. I think we live in a bubble, and there are like 99% people out there that don't really care about it. And of course, complexity. I mean, I said like probably several thousand pieces of new information in a couple of minutes, and I didn't really scratch even the top of it. Then lack of integration with hardware wallets, because CoinJoin wallets have usually been hot wallets, and you don't really want to put all of your stash in the hot wallet. And last but not least, there is a scare of legal implications. So I'm really hoping that we are going to be addressing all four of these points by introducing Trezor and Wasabi collaboration, which will be launched later this month. And I think that's all from my side. And if there are any questions, I still think we have like 5 minutes, so I'm here to answer them. Sorry?
Can you go back a slide?
Yes.
I just really thought it was a really nice slide to finish on. Coinjoin easily with Trezor. Who has a question? I'll run towards you now. Anyone? Yes.
Can you hear me? I know that last year Adam Gibson did a workshop on coinjoins, and it seemed like one of the other issues that he talked about was that we don't really know who the other participants are, and it seems like another fear is that maybe all the other participants are a single entity that are targeting you. Mm-hmm. What are your thoughts on that?
Yeah, I think Max can probably give more elaborate answer, but my take is we should strive to make coinjoins as big as possible. And I don't know what's the current limit in Wasabi coordinator, but I think it's 150 inputs at least.
Something like that, yeah.
Something around that. And it's very hard to pull a Sybil attack if there are like 150 participants. If there are like just 5 participants, it's much easier. And if there will be, I'm hoping that this integration will attract even more people to CoinJoin, and I think we can start to raise this bar and limit up. So yeah, that's my answer there.
Okay, thanks.
Any more questions?
For example, if I want to go to an exchange them, can they refuse, like exchange them?
So the question is, what's the relationship, or how do exchanges look at CoinJoin transactions? And I guess that's really a question for them, not for me. But not all exchanges have the same, patterns of behavior, and some of them are marking all CoinJoins as something legal. They don't want to don't want to accept coins from CoinJoins. I know there are even some more crazier exchanges that are looking in transactions after you withdraw coins from exchanges, and they say, hey, you withdraw your coins from an exchange and you do it like a CoinJoin several days after. We don't like this, and I think that's really draconian. But what I also believe we are doing here, we are attracting really huge user base to CoinJoin. So I hope that earlier it was very easy for exchanges to dismiss CoinJoins as something illegal, but if there will be, like, I don't know, several 100,000 legitimate Trezor users doing that, hopefully they will change this behavior. And if they won't, then I guess they have a problem. So it's like a game theory / 4-dimensional chess we are playing here.
Super. I think we have time for one last quick question.
My name is Robert. I run a Start9 node. Now, what's the biggest justification in terms of legal to use CoinJoin? They're coming after the developers, right? Or maybe someone here, how you justify it?
How do I justify it? Yeah, for example, there's a pretty big chain in the Czech Republic who is selling electronics, and I really like buying electronics from that store by using bitcoins. But I don't really want to be revealing all my stash to them, and it's very easy if I don't use CoinJoin, because you can just look at the transactions on the blockchain and retroactively see, hey, so this is a person that buys electronics. I'm kind of KYC'd to this electronics vendor because I just ship these electronics to my place. And they're probably not doing that, but they could if they want. So if I use CoinJoin, then I'm basically putting a wall between the coin
have another round?